this idea of how many ways you could arrange the letters in your name would figure out how many passwords you could make. So this is the permutations of your names. Okay, we need a fairly decent student to start with. Any volunteers? Okay. You sure? No? You'll do it? No, you cause too much trouble. Yeah, you think so? Well, I don't know. Okay, come up. Write your name on the board. Make sure it looks nice. Oh, just a second. Make it nice. We'll use calligraphy. There we go. Perfect. Excellent. Now, if Caitlin wanted to figure out the total number of ways she could rearrange the letters to make a password, if she used all the letters, how many letters does she have in her name? 1, 2, 3, 4, 5, 6, 7. Would you agree that there would be 7 factorial passwords, right? Including, which would be a good one, how about a tin lake? That's easy to remember. Is that all the same right letters? Yes, perfect. Tin Lake. If you want to have that as her new nickname, you can. You see her in the hallways, she'll know that. Now, to figure out the number of passwords is easy for Caitlin because all the letters are different, okay? But, right, and some of you also have all letters different in your name. I could pick, right? But Carter and Matt, these are problems, right? Why are they problems? We won't go into all the reasons, but just for passwords, we've got some repetition of letters. So now, if Matt happened to spell his name with one small t and one big T, it wouldn't be a problem because that would still be 4 different letters and he would have 24 passwords. But the problem with 2 T's exactly the same, okay, is this and this are considered different if the letters are both different, right? Those would be different passwords. But if I mix up the small letter T's, it's the same password. Does that make sense? And so one password with Matt could be Tam, right? And that would have been different than Tam had those T's been different. But when the T's are the same, Tam and Tam are the same, right? So what do we do with repeated letters? Okay? With Matt, like this, would be 4 factorial, which is 24. With Matt, like this, there's only 12. Why is there only 12? How could we figure out that 12 if we knew that Matt with a big T and little t was 24? Well, the easy answer would be like, well, you just divide it by 2, right? And that will work because every time, if you listed all 24 of them, does it make sense that there would always be a pair that's the same? If you listed them with a capital T and a little t, there would always be a pair that's the same, just with the t's mixed up. And so when we have those identical objects showing up, we would have to divide by 2, right? We have some other, right, issues in the class, like summer. Same thing, the double A. I know, exactly. Perfect. Normally it would be 5 factorial, but because of the double A's, we'd have to divide by 2, and there would only be 60 passwords. Now, are there any real big issues in this class? Does anybody have a letter 3 times in their name, or 2 double letters? Do you know? Jesse. Oh, yeah. Good thing he's not here today, otherwise the class would probably already be falling apart. Jesse would normally be 5 factorial, but because of the double S's, that would cut it in half. What do you think the double E's would do? Cut it in half again. And so Jesse would only have 30 ways that he could rearrange the letters in his name. Can you think of a short name that has 3 letters the same? Or even just a short word? It's got to be something. A short word with 3 of the same letters. This is hard? But I just want one letter repeated. Anything else is the same. I keep changing the rules. Ha 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 has 3 H's and 3 A's, but I just want 3 of one letter and something else. Are you Googling right now? Have you found something? Not you. Google man behind you. Yes? Geese. Perfect. I love geese, especially on soccer fields. Geese has 3 E's. So normally we'd have 5 factorial. What do you think we have to divide by because there's 3 E's? I like how everybody's so scared to answer. Who wants, right? What's the question? Well, with two letters the same, like summer, 2 A's, we divided by 2. Okay? So with 3 letters the same, we're going to divide by 3. Perfect. That's wrong. But I wanted someone to say 3.
3 2s.
Nope, not 3 2s either. Well, kind of, but not really. How many, now if the E's were all different, okay, so let's do little e, capital E, S, and then, oh, like the belongs to E, there we go. Let's just keep it mathematical. If we had those 3 E's, I would like you to tell me a different way I could spell geese by mixing up those 3 E's. What should I do next? Capital E, then little e, and then math E. Okay? Is that the only ones? No, what else could I have? What would be first? Well, the number E and the letter E look the same, so we can't. Although it's a good idea. What should I start off with? If I want to make it different. Mathy. And then capital E. Number E. I like that. Okay. Is that the only three? No, there's more. What's another one? What could I start with? Little e, then mathy, capital E. Good. Capital E, mathy, little e. Are there any more? Yes, what's the next one? Mathy, little e, capital E. What did we do? We figured out how many different ways we could put those e's in there, into those three spaces. We had 3 decisions to make. We had 3 choices for the first decision, then 2 choices because you had to use a different e, and then only 1 choice left, which is the same as 6 or 3 factorial. So the number of ways of arranging geese is if you wrote out all 120 of them, there would always be a group of 3 factorial or 6 that would be the same. And so when you have identical objects, these are all the same. That would only count as 1 permutation. So with 3 e's, we would have to divide by 3 factorial. In fact, we could have done this here because 2 is still 2. 2 factorial is 2. So technically we were dividing by 2 factorial, but it was just 2 because they're the same. But once we get to 3 of something, we would divide by 3 factorial. And this is called, oh, they had geese. Is that where you got it from? Yeah. Oh. You guys continually impress me and then disappoint me. There's Pee-wee, 4 e's. That would be 6 factorial over 4 factorial. And we get to permutations with identical objects. And if you have identical objects, you have to divide out the identical permutations. So it just becomes n factorial or r factorial. Or if you have even more letters, you would have more of them. So the question now we have to add is there identical objects in our question? So here's example 1. Okay. There are 7 boxes of cereal on a shelf. 5 boxes are bran cereal, identical. 1 puff wheat, and the other box is granola. You get busy trying to arrange your cereal boxes on the shelf to find out what looks the nicest. I don't know why, but this is what you've decided to do. How many ways can you arrange those cereal boxes on the shelf? How do we recognize this as a geese question? Well, there's identical objects. There's 5 bran cereal boxes, 1 puff wheat, and 1 granola. So this is like a geese question, except the word that we have is a bunch of B's, a P, and a G. So normally, if these were all different letters, there would be 7 factorial ways you could arrange them on the shelf. But for some reason, someone in your family found bran cereal on sale and decided to buy 5 boxes 5 years ago, only to find out nobody eats bran cereal in your house. So the number of ways you can arrange those on the shelf, you would have to divide by the identical objects, which is 5 factorial. Okay, and this is a good one for mental math. What's the answer? 42. How do you do that mental math? You expand the bigger one until you get to the smaller one. The 5 factorials would cancel out, and it's just 7 times 6, which is 42. Questions for practice on this one? 3, 4, 5, and 6. And also figure out your last name, how many permutations you could have of your last name. Zita, I think you have the most boring permutations names there can be. Even if we combine first and last name, you would have the double A. But other than that, oh, we're still recording. Here we go. It's good. So conclusion is Zita is boring, and that's how we'll end the video for today.